9.6 counting principles. So we're going to be counting the ways we can do things. So then we can find the probability of how to do things. So 8 pieces of paper are numbered 1 through 8 and placed in a box. Yes, you have to read. Okay?
I looked at the assignment and it's all word problems.
It is.
All of them.
It is.
It's like I can't
And
read. There's not a single non-word problem.
so when you guys are reading them, I would suggest you read them once and read them again so you know what it's really asking you.
Yeah, Riley.
I specifically,
Word problems.
I personally would read the question first and then read the problem. That's how I do word problems. So it says, how many different ways can the sum of 12 be obtained? That's our question we're asking. So 8 pieces of paper are numbered from 1 to 8 and placed in a box. 1 piece of paper is drawn from the box, the number is written down, and the piece of paper is replaced. Then a second piece of paper is drawn from the box, and its number is written down. So how many different ways can I find the sum of 12 out of what numbers? 1 through 8. So I have the numbers 1 through 8, and I want a sum of 12. So what's one way I can get 12 out of 1 through 8?
6 and 6.
There's only 4 and
No,
Oh.
we wrote it down and we put it back in
4 and 8.
because it says it's replaced.
4 and 8.
So I got, if the first one is 4 and the second one is 8, what
8
if?
and 4.
What about 8 and 4?
7 and 5.
7 and 5. 5 and 7.
3 and no, I was gonna say 39 and then not 9.
Are there any other ways?
6 and 6, but they're reversed.
Right, and we can't tell which is the 6, right? So 6 and 6 doesn't give me 2 different ways because it's the same piece of paper. Okay, so how many ways can that happen? 5. So 5 different ways. We just counted, right? Okay, that wasn't bad. So we have with replacement and without replacement. And Savannah said, no, there isn't. There's not another 6. There's not another 6, but we did replace it. So could we draw it back out? Yeah. So that means we replace something and without replacement.
Before.
Okay. So now, how many ways without replacement can I get 12?
4. Can't have 6 and 6.
I can have 4 and 8, 8 and 4. I can have 7 and 5 and 5 and 7, but I cannot have 6 and 6 because there's only 1 6 in the box, right? So that is 4. So without replacement, are the number of ways going to be less?
Yes.
Yes. Almost every single time. So when you are reading the problems, do you need to make note of with replacement or without replacement?
Yes.
Yes. Okay, what if there are too many ways to count than to count? Like you can't count them all. What happens then?
You multiply the number of ways an event can occur.
Okay, so Cadence read. We have the fundamental counting principle. It's multiply the number of ways an event can occur. It can be extended as much as needed. Excuse me. So we have how many ways the first time, times the second, times the third, and so on. So let's use it. How many people do we have in the room?
6, 7, including you.
Okay, because I'm a person. Thank you. Okay, so if we were going to line us up in a line, how many ways can we pick the first person?
No.
No, 7. Not by height.
I thought you were saying how many.
That would be how many
ways
different
to do it.
characteristics, but that would be endless. Okay, 7. I love it. 8. Us short people got to hang in together. Okay, now the second person.
7,
Nope. You have one already standing there. 6.
5, 4,
1.
3, 2, and 1.
Why do you go in order? That's what I'm
Well, because that's how it works.
No.
Okay, so we have 7 for our first choice, 6 for the second, 5, 4, 3, 2, 1. What does that look like? What we did yesterday. In other words, we have 7 factorial. Yes? And so what do we want to multiply together? 6 and say we want 36? Or do we want to go? So this is 2, 6, 24, 120? 720? No. Yeah, 720. I usually know up to 6, good. And then I have to multiply 720 by 7, right? So that's 0, 4, 49, 50. 5,040 different ways we could put 7 people. You gonna write all those ways down?
Nope.
No.
I am.
Didn't we do something like this in science last year where you have to like, it's all like the detective things with the DNA? And you have to-
Yeah.
Yeah.
And you have to write out all the different like amounts of like,
Ways that they can be put
you
together.
know, like do 1, 2, 3, 4, 5, and you
Yeah,
have
it's
to
like
write
little
out all
chunks
the
of
different
DNA that you put
combinations.
together.
So if you would have known this, would you have had to write them all out?
Yes.
Oh, because he was making you write them out? Okay. Well, this would be a number the way you could check that you had the right number. I can tell you I took a probability class. The whole thing was probability. So our first day was just this. And I'd write out everything. I'd write out 50 of them just because I thought it was fun. He's like, stop writing them out. You don't have time to do that. Because look how big they get really quick, right? So, okay, how many different pairs of letters from the English alphabet are possible?
There's 26 letters. So, based off that.
Is it 26 factorial?
No, because it says what?
Oh,
Oh,
pairs.
pairs.
13.
No. There's way more than 13.
Well, 13.
Well, okay, we're going to pick our first number. How many options do we have for our second number? So first number, there's 26 options.
25, 24, 23, 22, you get it. All the way down.
So there's 25. Wouldn't that just be it?
24? Why would that be it?
Yeah, because once you pick the
Because once you pick the first letter, you just pick a different one. Why do I got to write them all out? Because
Fine.
I'm only doing how many? 2. So I got to take 26 times 25. I almost said 3 plus 2 was 6. Really? I got 650. What'd you guys get?
650.
Okay. So there's 650 different pairs. Now, if I asked how many different ways you could order the English alphabet, that would be 26 factorial, wouldn't it?
Mm-hmm.
And that would be a lot. If you guys have your calculator, get out, dust it off. I'll show you where the factorial button is.
I was looking so hard for that last night and could not find it. I had to use Desmos.
It's on your calculator. My computer evidently today is having a hard time. Okay, so I want 26 factorial, so you put 26. And remember the button that if you don't know where it is, it's probably in that button? Math? And you see up at the top where it says probability? Do you see factorial?
Where's math? 4. Oh,
4.
math is under.
Okay, now, what does that E mean? It means exponential notation. So this is actually 4.0. You could write all those numbers if you wanted. times 10 to the what? 26th. That's a big number. So let me see. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I would have to put 17 zeros behind it. I don't even know how to say that number, do you?
I don't even know how to look at it.
Well, it's not that big of a number, it's just really long.
Well, first, you know it is, too. Because without the zeros, it's 4 trillion, but you have to put 17 zeros behind it.
It's only like 4 though, isn't it?
What?
4 point, and then?
No, you have to move the decimal 26 places that way.
Oh, okay.
So without the 17 zeros, it's 4 trillion. No, billion, sorry.
All isn't moving the decimal point.
Yeah, you have to move the decimal point.
Okay.
That's how scientific notation works. Okay, now if I forget about the math button, I can also find it through the catalog button. And you see a catalog button? It would be second. Anybody see it yet? It's right on 0. You see, look on 0. You see it in your second color. Okay. Catalog gets you to everything. It's in alphabetical order. So if you know what it's called, then you hit the key. Like if I said it was started with a T, I could hit the T key, which is what key? 4. And it would skip me to the T's, right? But exclamation point is a symbol, so that's probably at the end. So if you just go up instead of down, you should be able to find it. The catalog finds it for you, but is it going to take you longer? Should find it for us. Didn't it all?
Yeah, it's right under C train.
Right there.
Oh, I missed it.
There's the degree symbol, and then there's the factorial. So, I want you to get out of that. And I want you to hit second enter so we don't have to go find the factorial again. And back arrow. And make this 84. Factorial.
Good error.
You should get an error. Did you guys get an error?
Yeah.
Overflow.
Overflow. It is too big. Go ahead and go to. So we did 26. What do you want to guess that it stops at?
6.
Well, we did 26.
27.
Yeah, like 6 point.
Oh, 27? Nope.
30.
38.
30 is good.
28.
48.
50.
83.
I think it's 54. Nope.
No, it goes to 60.
60 works? So like 65?
70 doesn't work.
So let's do 64.
70, 65 works. 69 works.
So if 69 works, then 7 and 70 doesn't. Bless you. So the cutoff it will do is 69 factorial. I won't do any bigger than that.
Ha ha ha.
Stop.
Keep your way. I'm not telling you my story now.
Okay, so that's 98 zeros. Well, not 98 zeros. 2, 4, 6, 8, 9. So it is 89 zeros after all those numbers. That's huge, right? Desmos will do more. Okay, back to our notes.
Yay.
We'll do 69.5 too.
It will.
Mm-hmm.
So 70 must be the
But it won't do 60.
But how does it do 69.5? I wonder. Because then does it go 55.5 or does it go by halves? That is something I need to look into.
No, it's not.
I think so. I think I need to figure that question out because I didn't think you could do factorials with partial numbers.
Well, good thing none of ours are partial numbers then.
No, none of yours are. Okay. So, a telephone number in the United States currently has 10 digits. The first 3 are the area code, the next 7 are the local telephone numbers. How many different telephone numbers are possible within each area code? Note that at this time, a local telephone number cannot begin with 0 or 1.
Oh no.
Okay? So, it says how many different telephone numbers are possible within each area code. So I don't need to worry about the area code, do I?
So we have to do 7.
So I need the first 3 and then the next 4. Okay. Ainsley, what were you saying?
It'd be just 7. Yeah.
Well, there's between 0 to 9 is how many digits?
Well,
10. So 10 minus 2 is
8.
8. You forgot 0. That's what I was getting at. Because it can't be 0 or 1, can it?
No.
Okay. So how many choices do I have for my next number?
2, 3,
7.
2, 3.
Does it say I can't repeat any numbers?
7,
No.
8.
No. So how many?
8.
It doesn't say I can't repeat. So how many numbers are between 0 and 9? 10. How many choices do I have for my next one? 10. And my next one? My next one?
Oh.
And my next one?
I get it.
And my next one?
10.
So I have 8 and how many zeros? 6?
Yeah.
So there's 8 million different numbers in one area code. Well, several years ago, they ran out of 402 numbers. So you guys' area code is 402, right?
Mm-hmm.
And the map for 402 used to be big. Like, it was up to, like, I think Cortland was even 402. They have to have different area codes. I think Lincoln has 3 different area codes now.
I
I think it's 3 different area codes now.
4.
Why do we have to have so many area codes?
With people that need numbers.
Okay,
Different
so when I was a kid, your house had one phone number. Okay, and then by the time I was a teenager, if your parents were nice, or actually if your parent ever wanted to use a phone in their life, they got you your second line. Okay, so we only had like 2 for a house of 5 people. But now when you guys have a house of 5 people, how many numbers do you probably have? 5. 6 if you have a house phone still. How many of you still have a house phone?
My grandma does.
Grandma does. We had a house phone up till like a year ago because our internet's through a phone company, and to have the internet you had to have a phone line until about a year ago. Then they said you don't have. But no one called us. Like if the phone rang, my kids are like, we're not answering it.
Me and my sister used to race each other to answer my grandma's.
Mm-hmm.
And then, because they had like the long stringy one.
Oh, so they had the cord that. Okay, so when I was a kid, you take that cord because we didn't have cordless to start out with, and you take the telephone cord and you'd stretch it as far as you could get to probably get the most privacy. And then when you've done that forever and ever and ever, the cord is just this tangled, knotted mess, and yeah.
And then we would like stretch the phone cord all the way into the living room to take it to my grandma.
Yep.
Somebody for her.
My grandma had
You're like, Grandma, let's get a cordless.
my grandma had like these 2 house phones, but like you could hear the conversation on the other one.
Yep.
Yeah, because they all had the same.
Yeah.
They all have the same
So
number.
I just sit there and listen to everyone's conversations.
Yeah.
That's
My
awesome.
grandma had one in the kitchen and then one in her bedroom.
Yeah.
Stay in her bedroom.
So we had one in the kitchen when I was really little, and that was it. And then we had one in the kitchen and upstairs when I was a teenager so we could talk upstairs, I guess. But you'd pick up the phone really quietly and try to listen. But then when I got my own phone line, we didn't have to do that. When call waiting came around, it was the worst thing in the world because you had to hang up the phone. Because if it was your parents calling and you didn't answer, you get in trouble. I had a Swatch phone. They made watches. And you picked it up, pulled it apart, and you could talk on both the base and the... So phones have come a long way. I think about my mom, she had a party line. Do you guys know what that is?
No.
Don't you have to-
There would, like, on one line, so if you go down one street, let's say we went down one street, there'd be one telephone line. And everybody on that line
Could get on.
would use the same phone. So you'd have different rings for different houses. Like your house might be 2 quick rings, and the next one maybe just 1. And little kids all the time got into trouble because they'd answer the phone and just listen to their neighbors' telephone conversations. So we have come a long way from...
I want that.
That's
I need to
crazy.
see.
That's a weird thing.
It is.
I feel like my neighbors talk crap.
They're talking about you.
Well, they
Okay.
have 4 families.
I need to look in a book real quick and see if we need to keep going or stop for today.
Stop.
Well, I don't want to stop too soon.
I do.
You want to have all the notes you need, don't you?
Not necessarily.
Page 663, right?
I need to tell my mom to find my apron for me.
And you're going through number 30?
Yeah, 33. No, 30. No, 30.
Okay, we're good.
Bill,
Yeah.
So we're done for today.
That's what you said.